Hello dear students. Today in this session we are going to learn an interesting concept in social network analysis, how consistent relationships are in a social network. So we already know that a social network contains nodes and edges. Here a node can represent a student and an edge can represent a relationship between two students. But relationships are not always simply connected or not connected. For example, suppose we have three friends, Arun, Bala and Charan. Arun and Bala are friends. Bala and Charan are friends. Now we need to ask, what is the relationship between Arun and Charan? If Arun and Charan are also friends, the relationships are consistent. But if Arun and Charan are enemies, then we get an interesting situation. So, in this session, we will learn how to identify whether relationships in a network are balanced or unbalanced, how people assign status, and finally, how we determine whether two nodes are similar. So, that is the social balance theory. Uh, for example, let us start with the social balance theory. The basic idea is very simple. People prefer relationships that are socially consistent. We can represent relationships using positive and negative edges. For example, plus means friendship, minus means enemy. Suppose A tends to be equal to plus, that means A and B are friends. Now suppose B tends to C equal to plus, B and C are also friends. So what should we expect about A and C? Usually, if A and B are friends and B and C are friends, we expect A and C also be friends. So plus friend is a friend. This creates a balanced relationship. So in the past social balance theory, there are possible combinations. The important statement is for any cycle, if the multiplication of edge values is positive, the cycle is socially balanced. For example, friend equal to plus 1, enemy equal to minus 1. Then we multiply the signs around a cycle. If the result is positive, the cycle is balanced. If the result is negative, the cycle is unbalanced. So for example, we will take the first graph. So plus into plus into plus is plus. So this is balanced. So the plus into minus is minus. So likewise, while multiplying the signs through the circle, if it forms plus, it is unbalanced. If it forms minus, it is a negative. Two friends and one enemy. In the first one, three friends. In the second one, two friends and one enemy. Likewise, one friend and two enemies. Likewise, we are having the patterns. So based on this, we can decide whether this relation is balanced or unbalanced. So then social network theory, the slide defines status as how prestigious an individual is ranked within a society. It then considers how consistently individuals assign status to their neighbors. So balance theory mainly asks, are the relationships consistent? Status theory asks who is considered higher or lower in status. For example, imagine our department. We may have student, class representative, student coordinator, faculty coordinator and head of the department. These positions can represent different levels of status or authority. In a social network, we can represent this using directed edges. Simple example, A tends to be equal to plus. A has higher status than B. A tends to C equal to minus. A has lower status than C. So in this example, unstable configuration and a stable configuration is represented. So let us understand this using students. Imagine three students A, B, C. Suppose A thinks I am higher in status than B. So we have A tends to B is plus. Now suppose B thinks I am higher in status than C. So B tends to C equal to plus. This is a stable status assignment. But suppose A greater than B greater than C greater than A. Now we have a circular situation. A greater than B, greater than C and greater than A. Who is actually at the top? There is no consistent ordering. Therefore, this configuration becomes unstable. So think of marks in a class. If Arun equal to 95, Bala is equal to 85, Charan equal to 75. Then A greater than Arun greater than Bala greater than Charan. There is no contradiction. But if everyone claims to be higher than someone else in a circular manner, the status assignment becomes inconsistent. So the next one is similarity. So in similarity, there are two types, structural equivalence and regular equivalence. So now we have completed balance and status. So next we will have the completely different question. How similar are two people in a network? Suppose I have two students, Ravi and Priya. They may not know each other directly, but both may have the same classmates, the same teachers, the same project team, the same clubs. So although Ravi and Priya are not directly connected, their network positions may be very similar. This is called a network similarity. So the next one is structural equivalence. So two nodes are structurally equivalent when they have similar or shared connections. Imagine two brothers. Both brothers may know their mother, their father, their sister, grandparents, relatives. So their neighborhoods overlap significantly. Therefore, they are structurally similar. Suppose student A is connected to faculty X, Y and student PQ, and student B is connected to faculty XY, student PQ. Their neighborhoods are almost identical. Therefore, A and B are highly structurally equivalent. This is the structural equivalence. So then we will use the structural and equivalence, Jacob and cosine similarity. So Jacob similarity compares two sets based on their intersection and union. So this is the formula of Jacob similarity, first one. So for example, we are having the neighbors of A and neighbors of B. So we will intersect, so we can have the common neighbors. So union in the sense combination of all the neighbors. So this is the Jacob similarity and cosine similarity. So cosine similarity is, instead of treating the neighbors only as sets, we can represent the nodes using vectors. So A equal to 1, 1, 1, 0, B equal to 0, 1, 1, 1. So this is the Jacob similarity, this is the cosine similarity. So the one means the node has a connection to that particular person, then cosine similarity measures the angle between these vectors. So cosine similarity close to 1 are very similar. So close to 0 means little similarity. So this is the similarity examples. So we are having the vertices V1 to V6. V1 to V6. We will calculate the Jacob similarity of V2, V5. So the neighbors of V2 is V1, V4, V3. And then neighbors of V5 is V3 and V6. Then we will intersect here, and in the denominator we will calculate the union. So the next one is similarity significance. So now we have calculated similarity. But there is an important question. Is this similarity actually meaningful? Suppose two students have three common friends. Is that a big deal? Maybe yes. But what if almost every student in the college knows those same three people? Then having three common friends may not be special at all. So we need to compare the observed similarity with that we would expect by chance. So if observed similarity is much greater than expected, the similarity may be significant. So the next one is normalized similarity. So the idea is, students sometimes a raw similarity value is not enough. Why? because different nodes can have very different number of connections. For example, student A knows 5 people, student B knows 50 people. If they have 5 common friends, we cannot interpret that in the same way for both students. So we need to normalize the similarity. So simple analogy is, suppose student A scored 8 out of 10, student B scored 80 out of 100, both scores are actually 80%. So raw numbers can sometimes be misleading. So that the normalization puts values into a comparable scale. So this is the normalized one. So next one is Pearson correlation coefficient. Now we will connect the normalized similarity to Pearson correlation. Pearson correlation measures how similarly two variables behave. The range is explain the three important cases: R equal to plus 1, perfect positive relationship. When one increases, the other also increases consistently. R equal to 0. No linear relationship. So R equal to minus 1. Perfect negative relationship. So when one increases, the other decreases consistently. So the next one is regular equivalence. So structural equivalence look at shared neighborhoods, whereas regular equivalence looks at how neighborhoods themselves are similar. So structural equivalence. Do these two people have the same neighbors? Regular equivalence. Do these two people have similar kind of neighbors or may play similar roles? So this is the difference between the regular equivalence and the similar normalized similarity. So the next one is regular equivalence. So the important idea is that similarity is determined recursively. That means if two people have neighbors who are themselves similar, then those two people can also be considered similar. This is different from simply counting common neighbors. Suppose A is connected to B and C, another node and another node D is connected to E and F. Suppose B is similar to E and C is similar to F. Then A and D become similar. Even though A and D may not share the same direct neighbors, we can say that A and D is similar. So it's like saying your friends are similar to my friends, so your social role may be similar to mine. So this is the regular equivalence. So the next one is regular equivalence and matrix. So we can move to the mathematical representation, similarity using matrix. Suppose we have four friends A, B, C, D. We can construct a matrix where rows represent nodes, column represents nodes. Each will represent the similarity between nodes. So this is the regular equivalence. So the regular equivalence example. So this is the matrix. So vertex 1, 1, 2, 3, 4, we are having 6 vertices, so 6 rows and 6 columns. If there is a connection, it represented by 1, otherwise 0. Then the similarity is calculated by using the value 1 I minus 0.3a. So the similarity of each vertex is 1.143, 0.73, etc. like this. So this is a simple concept of regular equivalence. So at the end of the session, balance represents or relationships consistent. So friend plus friend plus friend is an balanced. Status. Who is higher or lower in status? A greater than B greater than C. If the ordering is consistent, it is stable. And then similarity. How similar are two nodes? There are structural equivalence and regular equivalence. And then Jacobi similarity. So common neighbors divided by total unique neighbors. And then cosine similarity. We represent nodes as vectors and compare the angle between them. And then Pearson correlation. We compare two variables or network patterns changed together. So this is the session. So in this session we have learnt about balance, status, structural similarity, regular similarity, Jaccard similarity, cosine similarity, and Pearson coefficient. So thank you, students.